In their 2026 paper for the Journal of Metaverse, Karaarslan and Aydın present a functional policy framework for governing artificial intelligence in academic publishing. Academic journals globally are currently processing a massive surge in manuscript submissions. The sheer volume is straining traditional editorial systems beyond their capacity. The publishing industry's answer to this bottleneck is scale through automation. Major publishing houses have fully deployed natural language processing, large language models, and semi-autonomous AI agents to handle the initial triage of incoming papers. These tools deliver immediate operational efficiency. They accelerate desk screening, assist non-native English authors, and automate complex integrity checks. However, relying on them introduces severe systemic vulnerabilities into the peer review process. Karaarslan and Aydın identify 3 specific failure modes currently affecting operations. First, large language models hallucinate, generating highly plausible but entirely false claims. Second, vision language models trained on skewed datasets misclassify figures from underrepresented domains. Third, uploading data into third-party AI platforms risks leaking confidential peer review data. This table outlines the resulting dual-edged paradigm. Every single operational efficiency gained by an editorial board is strictly counterweighed by a corresponding ethical or systemic risk. By deconstructing the Karaarslan and Aydın workflow, we can trace exactly where these risks materialize and why artificial intelligence must remain strictly an administrative substrate and must never be allowed to act as a definitive judge of scholarly merit. Failing to govern the precise handoff between machine efficiency and human oversight threatens the core mechanism of peer review. Without clear boundaries, the foundational epistemic trust of the global scientific record breaks down. This flowchart maps the editorial life cycle. Notice the structural division, a blue automation layer parallel to a green human oversight layer. In Phase 1, authors use language models for grammar, but must disclose this. In Phase 2, NLP agents extract metadata and verify formatting. This is also where automated systems screen for undisclosed AI-generated text. They do this by measuring 2 variables: burstiness, the structural variance in sentence length, and perplexity, the predictability of word choices. AI-generated text consistently registers low on both, resulting in a flat, highly predictable linguistic pattern. These tools create an administrative threat. Because AI simplifies manuscript drafting, journals are flooded with submissions that are structurally sound and highly presentable. This volume surge artificially lowers acceptance rates. Human editors must dedicate more time sifting through presentable formatting to locate genuine contributions, heavily increasing their workload. While initial automation clears the immediate administrative bottleneck, it perversely creates a denser, harder-to-verify backlog. Rigorous human verification becomes the only filter against quality dilution. Once a manuscript clears triage, the workflow moves into Phase 3. Here, the process shifts from basic text formatting to complex contextual evaluation. This network graph illustrates how AI reviewer matching systems operate. By analyzing massive databases of citation graphs and keyword co-occurrences, these agents actively recommend highly specific, viable peer reviewers, reducing assignment delays. However, simple keyword matching is insufficient for accurate peer review. Human editors must manually verify the actual expertise of the suggested reviewers to ensure they align with the precise nuances of the study. This leads into Phase 4, the review and decision stage, the most sensitive point in the pipeline. Here, the institutional prohibition is absolute. Editors may use language models to summarize reports, but the final acceptance or rejection rests entirely with human scholarly judgment. Integrating AI at this stage carries severe confidentiality and intellectual property risks. Uploading unpublished manuscripts or sensitive decision letters into public generative AI tools directly violates non-disclosure tenets and exposes proprietary data. The risk is actively expanding. A recent survey of 1,600 academics revealed that over half admitted to using AI in their article review processes, creating a dangerous layer of shadow algorithmic governance. Human scholarly judgment is the mechanism that generates academic value. Delegating that judgment to algorithms removes the qualitative friction required to validate truth. If a paper clears the human review process, it enters phases 5 and 6, where the accepted manuscript moves into XML production and post-publication dissemination. Journals utilize generative tools to transform static PDFs. Complex papers are rapidly synthesized into structured infographics and interactive overviews, significantly enhancing research visibility. The immediate risk of multimedia synthesis is the oversimplification of data. Automated tools prioritize pattern recognition over contextual depth, which flattens complex arguments and strips away vital methodological nuances. To mitigate this, journals implement a mandatory governance policy. Authors must explicitly review and approve all AI-generated promotional content before public release, ensuring scientific integrity is preserved. Metaverse research poses distinct methodological risks. These studies frequently rely on synthetic environments, AI-generated avatars, and simulated behavioral data rather than traditional human datasets. This creates the threat of simulation fraud. In virtual experiments, it becomes extremely difficult to distinguish authentic human participant activity from data generated by automated synthetic agents. Combating simulation fraud requires strict transparency protocols. Authors must provide exhaustive documentation detailing environment configurations, model parameters, and exact versioning when using synthetic agents. As the mediums of research become increasingly synthetic, the evidentiary burden on the human researcher to prove authenticity exponentially increases. Managing these procedural risks requires moving from individual workflows to a unified global policy layer. This matrix compares AI guidelines from COPE, the ICMJE, Elsevier, and the Journal of Metaverse. One universal consensus exists: AI tools cannot be credited as co-authors. Furthermore, mandatory disclosure of AI assistance is required to maintain transparency. The primary strategic takeaway of the Karaarslan and Aydın analysis is clear. Algorithmic systems scale workflows effortlessly, but they possess zero capacity to take epistemic responsibility for the claims they process. Artificial intelligence accelerates the administration of science, but the integrity of the scientific record relies entirely on human friction. Researchers, editors, and peer reviewers must actively audit their own institutional workflows against these established frameworks. In a publishing ecosystem flooded with automated content, strict human-in-the-loop governance is the only mechanism that preserves institutional legitimacy.